Okay. Good morning, everyone. How are you doing today? Good morning, online. Thank you, Tejas. Good morning. Okay, so hope you are doing good. Did you completed your practicals? Completed? Everyone? Thank you, Naveen. So you wrote that manifest file? Hmm? Nice. What's wrong? Okay. Ubuntu, correct? Acha. Baba. Thank you, Dhaneshwar. Okay, ma. So clear. Host name, CTL, set hyphen host name, Minikube. Acha. Host name, CTL, set hyphen. Set hyphen host name Minikube. Sudo hyphen I. Okay. So vi mini.sh. Let's take this, paste it. Okay. So this will take time. Fine. So what did we discuss in our last class? Yeah, manifest file. So in that manifest file, what are the mandatory parameters that we have? API version, kind, metadata, spec. And API version is like a code library. Kind is the object that we create. Metadata is the information about that object that we create. Spec meaning specification of that object that we are creating. Okay. So we created the pod using the command. Also, we created the pod using manifest file. And also next we went for which kind? Replica set. So because when you create a pod, so if it got deleted, you don't have any high availability for it. So if you need to have a self-healing and the high availability, then we go for what? Replica set. So before the replica set also what we have replication controller. Did you try replication controller? And that's why I gave you, no? Could have tried it today. Okay. So try replication controller, but that is not much used. So first we got replication controller. After that we got replica set. So what is the drawback of replica set? You cannot update the application. You cannot roll out the applications, right? So, and you cannot change the image. If you change the image, application rollout will happen. New image will come, right? So you cannot do it. So for that reason, we go for deployment. Which kind? Deployment. So using this deployment, we can do nicely roll out roll-ins, right? And then we can deploy the new application. Everything we can do. Same thing. What we have. But the only difference is instead of replica set, we put what? Deployment. Then a replica set will create the pod. Do we create the pod directly? Did we anywhere mention the pod to create? No, replica set will create the pod automatically. But whereas here now deployment will create the replica set. Replica set will create the pod. In the previous one, replica set will create the pod. Initially we had a pod that is managed by now replica set. Now replica set is now managed by deployment. So when you create a deployment, automatically replica set will be created. Okay. So do you see this? I gave some definition of the Kubernetes deployment. So Kubernetes deployment is a high-level resource object by which you can manage the deployment and scaling of the application while maintaining the desired state of application. That how many, so we have, yesterday we mentioned replicas as 3, right? That's our desired state. And then we scale out and scale in or not? Manually we scale out and then scale in. So you can scale up, down, all based on the incoming traffic. And if you have performed any rolling updates, so whenever you find any bugs, you can deploy a new application. Everything can be done using what command? kubectl command. See, before we use replica set. Replica sets will create pods. Replica sets will create pods. Now, deployment can create replica set, and replica set will create what? Pods. So I have mentioned here, first delete any replica set that you have. So what's the command to delete it? kubectl delete rs ibrs. Yesterday we did. So what's the command to list the replica sets? kubectl get rs, and you know how to get the pods. So what we do is, let's go and set up our own, create our own manifest file. So instead of replica set, now we put what? Deployment. Do you remember the manifest file? Let's go. Clear. Minikube set status. Everything is good? kubectl get nodes. Nodes is also ready. So now let's go and call it as deployment.ym. Okay, go ahead. API version. Which API version is this? app/v1. Very good. Next, kind. Now this time what's the kind? Deployment. D capital letter. Okay. Next, what we have? Metadata. So what's the metadata, Nani, here? So inside the metadata, we need to put what? Name. Inside it, we have what? Name. What's the name of it? IB hyphen what? Deployment. You can give any name. So inside this, what we do? We put the labels. What's the label you're putting? App is what? Bank. What's the next mandatory field? Spec. Inside the spec, what we need to mention? Replicas. How many replicas? Here also I go for 3. And then what we have? Selector. What do we need to do? Match labels. So what is the label that you want to match? App bank. Okay. So inside this only what we need to create? Template. So inside the template, we need to mention the metadata. So what is the label that you are using? What is the labels that you need to mention? App as bank. So, and inside this, again, we need to mention the spec. What does spec contain? Containers. So what is the name of the image that you are using? Right? And what is the name of the container? Container 1. And the image that you are using what? Trainer Riaz / IB hyphen image colon latest. Are you guys using my repository for the image? Huh? Hey, tell me. No, right? So you're using your repository, right? Good. So in our last class, we learned all these things about it. So now what we did, instead of putting here replica set, now we are putting what here? Deployment. So how to run this? kubectl create hyphen f, which one? Deployment.yml. So deployment got created, Nana? Deployment got created. Okay, now what is the command to get the deployments? kubectl get deployment. You can say deployment, or you can say just deploy also. So here we have the name called IB deployment. Just now we created. And how many replicas are there? 3 replicas, and all 3 replicas are available. If at all you want to see, get what? Pods. Got it? And I told you, okay, what is the information? What is the command to see deployment more information? kubectl get deploy -o. Right. Okay, so I'll zoom in. Okay, what's the command? kubectl get deploy -o wide. Okay, so now this is the deployment. 3 are ready. Containers name is container 1. This is the image, and bank as selector is app is equal to bank. And I told you, whenever you create the deployment, it will create the replica set also. What is the command to get the replica sets? kubectl get. Very good. See, it is created the replica set also, right? So whenever you create the deployment, so automatically create the replica set. Replica sets will go and create what? Pods inside. Got it? Online, you're getting it now. So what's the command to describe the deployment? Tell me. kubectl describe deploy. Which deployment? IB hyphen deployment. So it contains the entire information about the deployment. If you want to see more information. Okay. Guys, is this clear till here? So now let's scale out. Let's scale out the deployment. So what's the command to scale out? kubectl scale RS, that is replica set we scaled out. Now what we need to scale out? Deployment. So here we need to put what? Deploy / which deployment? IB hyphen deployment. And then how many replicas that you want to deploy? For example, 10. How many are running now? 3. So if you want to watch live, what's the command? kubectl. I want full. kubectl get pods. So we are seeing the live of the pods, right? Not the deployment, right? So kubectl get pods and then hyphen watch. Okay. So if I hit 10, so now if you see kubectl get pods, so those are all creating. Good enough. You can easily scale out or not. So in replica set also, we also did the same thing. But the problem is what? Application, rollout application is not possible. Now here also we can easily scale out, and if possible, I can also scale in. Okay. All are running now. And now scale in. What's the command to scale in? kubectl scale deploy. Which one? IB deployment. Which one? replicas here. How much? For example, 5. So now rest of the 5 will get terminated or not? kubectl get pods. So those are all terminating. And now you have how many pods, Nana? Only 5. So as I said, whatever the replica set is doing, deployment also doing the same thing. So if you delete any pod also, it will get recreated or not? So let it get terminated all. Okay, now I have only 5, right? So let's go and delete one pod. Let's see whether it recreate it or not. What's the command to delete? kubectl delete pod and then pod ID. Whoa, this is a big pod ID. Why it is taking time? First the pod is getting created and then it will delete. So if you want, so you can open the duplicate. We can watch live. What's the command now? kubectl get pods hyphen watch. Hyphen W also you can use. What is that? Hyphen W. Okay, so it got deleted. Now if I say get pods, again I have 5 running or not? So because, so this is a self-healing mechanism is also there as the same as like our replica set. So if you take the watch live here, so all 5 are running at the moment. So do you remember yesterday I saw, can you tell me, how do I find out these pods are using which image? Tell me. kubectl. Very good. Describe. What? Pods. Hyphen. IPL. Right? So actually, as I told you yesterday, if you have multiple selectors, then you can put hyphen L and then put the selectors. App is equal to bank. But here, do you have any multiple groups, multiple selector? No. So just describe pods and then pipe. Which one? Grep hyphen I. Which one is that? I. Or also you can put image. Oh, okay. 5 are there, no? So do you see all are using here what? IB, IB, and then all are IB or not? Can you show how server load will change when scale out and scale in? Server load. Why do you worry about the server load? So that's so what is the Shahrukh? Can you tell me guys what is how much GB RAM it has? 2 GB RAM because we are using T2 small. So these are scale whenever the pods are getting scale out and scale in, pods are very small object in Kubernetes. So you don't get a huge difference in the server load. That's the reason why we use this microservices concept, right? Otherwise, if you are using monolithic and your application is going high, your memory, if you have given 64 GB also, it will go and put 63.5 GB, it will get occupied. So, but here it is. But if at all you are very interested to see, where do you go and check, Nana? Here we have refresh. We have what here in the monitoring section. What is here? CPU utilization. Do you see? Budak, it went up, right? And then Darel, it went down. Like the gold, it is going up now, right? Yes or no? Huh? Hope we will see the fall down of the gold also. Huh? These boys are gold, sir. What is talking about? When I say gold, see the girls will say, yes, sir. How much is gold now? Huh? 1 lakh, no? Okay. Yeah. Fine. So, Shahrukh Khan, Oh, Shahrukh, got it now? Okay, ठीक है. Uh, yeah. So here, do you see this here? We have IB hyphen image. So now we need to roll out. What we need to do? Roll out. So if we want to roll out, what we need to do? What is the command that we need to change the image? So I want to change to mobile banking. So where do you go and change? What is the command to change the image? Will you go and change the YAML, the manifest file? No. So what's the command? kubectl. Very good. kubectl. Edit. Which one you want to edit? Deploy or replica set? Deploy. Deploy slash which one? IB hyphen deployment. So here in the live, how many are there? 5. So now I'm just going in, editing it, and then change. Now I have a new image that is there in the Docker Hub. Someone has pushed it. You know how to push the Docker image. So assume that Docker image, new latest image got pushed. So now you need to modify that image here or not? So here is the image. So instead of IB, I'll put what? MB Mini? Mumbai? Mobile banking. Yeah. So now I save it. So once it is saved properly, it clearly says, do you see this here? Do you see what's happening? Okay. He like my slang maybe. Huh? Okay. So do you see this? A lot of things happening or not? So the old ones are getting terminated and the new ones are getting created. So if I do kubectl get pods, so those are terminated and new one got just launched. Do you see? 31 seconds. So previously was 10. So now let it run. All are running. Now let's tell me that command whether it is using IB image or MB image. kubectl, describe, pods, which one? grep hyphen I, which one? Image. What it is using now? So our application got rolled out or not? Yes or no? So that was the problem with what? Replica set. Replica set it cannot roll out. Now easily deployment is getting roll out or not? Now you tell me in the real time we'll go with the replica set or deployment? Deployment. Clear? I'm showing the clear differences between these two now, right? So for that reason, we go with what here? Deployment. Okay. So this is how you roll out. So I have few rollout commands with you. So here you can say kubectl, what is that? Rollout history. Say that. kubectl, rollout history. Which one? Deployment. Deploy slash which deployment? IB deployment. So what we can do is we can undo the rollout. We can undo the rollout. It can go back. Remember we have did where we did. It is going back to the how many pods in Dockers we did, right? Remember? So assume that in Docker you have 10 containers. If you want to roll back, we have rolled back to the previous stage or not. Similarly, also here also you can roll out. So if you want to roll out, so kubectl roll out, we need to do undo. What's that? Undo. Undo which one here? Deploy slash IB hyphen deployment. So roll back. Do you see? Roll back meaning it went to the previous deployment. You understood? It went to what? Previous deployment. So previous deployment meaning what it has? IB. It went to IB. So if you want to roll out, so you can roll out. You can also roll out. Just now we did roll out, and just now we did roll back. So previously from IB to MB we roll out, and if you want to roll back, you need to do here undo option. Is that clear, guys? Right? So with the rollout commands, you have nice commands. You can practice it. So do you see what we can do? We can pause the rollouts, and we can also When it is in past stage, can you undo? You cannot undo. That's why I say here, not possible. It is just like when you say pause, meaning you are locking it, the deployment. So no one, your junior or anyone has the permissions to do the rollouts or do the undo changes here. So, and if you want to get it back, what you need to do? Resume. And then you can do the undo. And if you want to do the status, you can do the status. So again here, can I do undo this? If I do undo, what will happen? Again, it will roll back. So if we do here kubectl get parts, so again, those are getting terminated and it is getting back. So like this, you can play with rollout and then rollback. Understood rollout, rollbacks in Kubernetes deployment? Online? No? Clear online? So whatever that we are doing in the manifest file, in the manifest file, did we expose the application to outside? No, right? So if you want to expose, we need to map the port numbers or not. So for that, what we need to create? In Kubernetes, if you want to expose the application, what we need to create? Service. What do you need to create? Service. So in that service, again, we have we have three types. What are those? Cluster IP, node port, and then load balancer. So if you want to expose the application, then we will expose it later. Now I'm just showing you about all the rest of the topics. Okay. So, but here I mentioned clearly, if you want to expose, so in the spec, we have mentioned the container, right? And here what we need to put? Ports. Remember, we have the container port and then host port. Container port meaning the port inside the container. That means your application is running and you need to map it to the host port or not. Like how we did it in the Docker. Clear enough? Okay. Sorry, I've done it. Is it clear till here, everyone? Online, is this clear? What's the command? You tell me, what's the command to delete the replica set? kubectl delete rs replica set name. So if you want to delete the deployment, so first you need to get the name or not. kubectl get deploy. So what is the deployment name? IB deployment. So what's the command to delete it? kubectl delete deploy and then IB hyphen deploy. So kubectl get pods. All are getting terminated. It's clean. Good one. Clear online? आपको तो समझ में नहीं. Why? Breaks. So if you miss the class, I told you Kubernetes will not understand. Okay. So now we have done on the deployment. So guys, I told you, I'll show you one manifest file to you. And you need to tell me what that manifest file is doing. Okay. If I show here, I'll open. Tell me. Hmm? That is the concept. So what is this here? What you said is exactly right. So one pod, multi-container. One pod. So till now what I have showed is only one pod, one container. So that is the ideal way of doing it. But generally you have that in back of your mind, right? So can we have two containers in one single pod? For that reason, I have wrote this manifest file. So you can easily understand. So API version, kind, metadata, name, two container pod. What's the labels I'm giving here? App, multi-container. And spec, and in the containers, how many containers I'm creating here? Two containers. What's the first name of the container? Nginx container. What's the image I'm using? Nginx. I'm exposing the port to 80 container port. And then what's the another container I'm creating inside it? BusyBox. BusyBox is a, what's the image I'm using? BusyBox is an image that's there in the Docker Hub. It's just a name which contain very basic things, right? So in order to do some test with the image, they use this BusyBox. As everyone are using, that's why they call it as BusyBox. So there is nothing inside it. It's just a name. It's a normal small image which contain a basic operating system. Okay. And inside this, I'm using what here? Command. Command meaning, you know, to run our Linux shell commands. So I'm using here sh. Oh, okay. You tell me what is this doing? This is a small shell script actually. Mm, but logic is not that. Printing hello from BusyBox. Okay, it is printing, but there is also one condition, no? What? So it is printing hello from BusyBox every 10 seconds. It is sleeping for how many seconds? 10 So every 10 seconds, it is printing it. So you can run anything, but I'm just putting a small command here. So if I take this and run it, what will happen here? Let's take it. Okay. So here, let's go and create multi cont dot y. So as is easy, I just took it. Okay. So how to create this? Huh? You didn't forget Docker, huh? Okay. kubectl. You can do create also. You can use apply. Anything is fine. So differently what I'm doing, apply -f. Which one? Acha, multi con dot YAML. Okay, clear. So if I do kubectl get pods, there is some difference there. Can you catch the difference? Hmm? Uh-huh. Okay, that will come. Okay, now catch the difference. Huh? No. Abage na maja bedu. What you are seeing there? You don't see any difference there? So previously it was 1/1. Now it is 2/2. That's a difference, no? Yes or no? Why it is giving 2/2? Because it has how many containers? Two containers, right? That's why it is getting 2/2. Okay. So can you tell me what is the command to see the logs of the pod? kubectl, kubectl logs, and then pod. Okay. kubectl logs to container pod. But if you run like this, it contains everything. But what I need is, I need the logs of, inside this I have two containers, right? What is the container name? Nginx container, and another one is BusyBox container. So if you want to list, if you want to get the logs of a particular container, you can put here -c. What's that? -c, container. Which container? For example, BusyBox. BusyBox hyphen what? Container. What is printing? It is printing hello from BusyBox. I told you it is printing every 10 seconds. So if you want to get the logs for a particular container, so you can use -c and the container name. So if you want to get the so another one, which one? Nginx. So if you remove this, Nginx container logs also. Okay. Now I want to log into Nginx container. Can you tell me how to do that? kubectl exec hyphen it pod name container hyphen pod. Next hyphen c. Very good. What is that? Hyphen c. Which one? Nginx hyphen container hyphen. So you can use bin bash, or also you can use sh, any shell information. So okay. So now you are inside the pod. Now what is, as it is Nginx container, it creates a default directory. No, let's go to that default directory. cd usr share slash nginx slash html. Is there? So we are not, that meaning we have logged into the container or not? Understand? No? So if at all, I just gave this information just for fun. So just in case if you have any requirement to create multi-container in single pod, this is how you create it. Clear? Online? So if you want to delete this, how do we delete it? kubectl delete pod and then pod name. Yes or no? That also you can do it. Or there is also another command simply. So generally, it's not good, but see that command. What I did? kubectl delete. If I use the manifest file, so whatever it has inside it, everything will get deleted. But that is, keep that in mind, but don't apply, right? But if at all you want to delete all the related dependencies of that manifest file that it has created, use kubectl delete -f and then manifest file. So that manifest file has what, Nana? Containers and pods, everything will get deleted. If it has a replica set also, it will delete. If it has a deployment also, it will delete. Instead of you going deleting the replica set deployment manually, so you just put kubectl delete -f and then manifest file. If you put like this, kubectl delete -f dot, whatever the manifest files that you have inside this directory, in that manifest, whatever it has, everything will be gone. But Bigilu, be careful, okay? Understood? Online, this is clear till here, please. CC till here, please. Okay, so now let's go to the next important topic in Kubernetes, which is called Kubernetes jobs. What is that? Kubernetes jobs. Generally, what is the purpose of job? To run the task. Yes or no? What is the purpose of the job? To run the task. So you can run the task, you can do the cron. Remember cron job we used on the particular scheduling. So basically scheduling the pods, right? In the scheduling it, everything will come under the jobs. So the next concept here is Kubernetes jobs. Okay. Daneshwar is saying jobs meaning salary. Not that jobs, okay? So Kubernetes jobs are resources used to run batch task in Kubernetes cluster. So if you want to run a particular task, so what you can do the Kubernetes jobs. Steve Jobs, all. So they ensure that the specified number of pods successfully complete a task before marking the job is done. So basically, you run some small command. Yeah, you run some small, you mentioned the small. Just now also in the multi-container pod, I have mentioned a command, right? So you mentioned that command, and this command needs to be executed these many times, or these commands will need to be executed at these many pods should run. So everything you can mention it here in the Kubernetes jobs. So jobs are crucial for executing one-time or recurring tasks such as data migration, backups, or any kind of batch processing. So mainly we have here 3 types of jobs. How many types of jobs are there? 3 types. In that, 2 are very important. Number 1 is non-parallel jobs. Say that. Say that again. So this will take little bit time for you to understand. So first listen carefully. So these job execute sequentially, that meaning one by one, with only one part started unless it's failed. The job completes as soon as the parts terminated successfully. So let's say, for example, you have running the command and you have mentioned that these commands need to be executed 5 times. That means how many parts will be created? 5 parts will be created. And this command will be running one by one. So one pod by pod, pod by pod. When the pod is getting created, pod will get created. Inside that, command will run. Next, another pod will create, command will run. Like this. So we call it as completion. What's that here? Yeah. What we call it here, Nana? Completions. Let's say, for example, you have mentioned the completion as 3. Do you see this? Completions as 3. That meaning how many pods will be created? 3. And whatever the commands that I have mentioned here. So in every pod, this command will execute. So in non-parallel jobs, remember, so what we need to mention here? Completions. As you mentioned the completions as 3, that meaning how many pods will be created? 3 pods will be created and 3 pods will be successfully run. Then only the job will completed. Job is the collection of pods. Here in this case, job is a collection of what and here? Pods. So if you mention the, so let's say you mention the completion as 5. That means how many pods will be created? 5. The pods will create, commands will run, whatever that you have mentioned, and the pods will be running terminated. It will run. After running, executing the command, the pods will get terminated or it will be running. It will be terminated because the job is done. No, the commands are there inside it are done. So 5 pods, you have mentioned the completion as 5. So that meaning 5 pods will get created one by one and commands will executed. One pod will create, commands will run and terminate. Next pod will create, commands will run, terminated. Like this, how many times will happen? Why I have given 5? Because completions I have given 5. Once that 5 is completed and the pods are terminated, that meaning your job is done. This is called non-parallel jobs. Non-parallel meaning sequentially. That means one by one it is running. One by one it is running. You understand? No? Okay, see. So, I'll take this example only. I'll take a real example. Visible? Huh? See, Nana, I'll taking a real examples here. Correct, Naveen. What is the API version I'm using this time here? batch. Remember I told you in the jobs, if you are using jobs, then go for batch slash. What's the command to see all the API resources? kubectl API hyphen resource. You remember the commands very nicely. Very good. So I want this memory power till you get the jobs. Once you get the jobs, shake your head, no problem. Because someone will be there, our notes will be there. Or if you do some self-healing mechanism, meditation, I'll come in your brains and then I'll teach again. Right, if possible. Okay, I'm just kidding. Okay, so batch here, batch slash VPN. And what's the kind I'm using here? Job. Metadata, name of the job. What is the it is non-parallel. So we have three types now. What is first one is non-parallel jobs. Say that non-parallel jobs. Second one is parallel jobs with a fixed completion count. We'll talk about it. Next is parallel jobs with work queue. So last one you can just ignore completely. So let's go with the first one, non-parallel jobs. For that reason, metadata I'm giving as non-parallel job. Next spec. Inside this template will run or not? So what is the template? Template metadata name non-parallel pods. Inside this I'm creating a container. What's the container I'm using here? BusyBox, and I'm running this container. I'm running this command. Don't worry about restart policy. I'll talk about it. Next here I'm giving what? Completion as 3. Here is the point. This one, everything you understood this here till here? Yes or no? That is our normal manifest file. So here when I say completions as 3, that meaning how many parts will create? 3 parts will create. How? One by one, na? Parallelly, na? One by one. That's called non-parallel jobs. One by one. That means sequentially. First, what will happen is when you run this manifest file, one part will get created. How many are there here? 3. That means it will be 1/3. One part will create. And what's the command I'm giving here? Echo hello from non-parallel job. This command will execute. One part will create, command will execute, part will get terminated. Because I told you, hey, you come, do the job and get killed. That is your work. So I'm telling to Abhi, you come here and give me something, go. That is his job. Right? So this command, this pod also, pod will get created, command will get run, and then pod is getting killed. One is done. Like this, how many it will get created? 3. One by one, parallel, one by one. This is called non-parallel jobs. Understood? So now here completions as 3. So remember, whenever you see completions as 3, that meaning it is non-parallel jobs. So 3 parts will get created, and automatically whatever the command that you have mentioned, not only command, anything that you have mentioned, one by one the parts will get created. This command will execute and then terminated. Once the 3 parts are created and terminated, that meaning this job is completed. This is online, understood, Anna? This is called what? Non-parallel jobs. What is this called? Non-parallel jobs. So coming to the parallel jobs, what is that? Parallel jobs with a fixed completion count. For that, we will write another parameter called parallelism. What's that? Total completions are 6. Completions are 6. That meaning how many parts? 6 parts. Parallelism meaning parallelly how many it will get created? 3. So 3 parts will get created parallelly. Commands will execute. 3 parts will get terminated. Next again 3. So this is called parallel jobs with fixed completions. The difference between non-parallel jobs and parallel jobs is in non-parallel jobs we have only completions, whereas in the parallel job you have parallelism. Whenever you have parallelism, that meaning you consider that is a parallel job with fixed. Online cities, is this clear or not clear? Online, you getting it? Very nice, very nice. So in the last one, parallel jobs with work queue, there you mentioned how many here? What you mentioned? Only parallelism. So parallelism meaning, so these three pods, I mean parallelly, how many pods will get created? Three pods will get created, job will done and get killed. Do you understand the differences here? Three. First one is completions. Second one is completion and parallelism. And third one is only parallelism. And then here I have mentioned restart policy as what? Never. What's that? Restart policy as never. That meaning restart policy, we have three commands, three options. What is here? Restart policy, you can put it as always. Restart policy, you can put it as what? On failure. And restart policy, you can put it as what here? Never. Always meaning whenever something happened to the container, it will try to restart. If the container is in exit state, it will try to restart. On failure meaning restart the container only if it exits with an error. Let's say container image that you are giving as BusyBox or Nginx. Assume that you have given name Nginx, image name as NX or Nginx something. You have given the wrong name. Will the container will get built? Will container will get created? So container will be in exit state or not? With error or not? In that case, on failure, again will container will restart. Whenever it says never, container will never restart. Now this is my job. Do you think that my container should get restarted? So the pod will get created and the container will also get created. The commands will execute and it will be terminated. That means container is deleted. The container is in exit state. Do you want me to restart it again? No, in that case, restart policy, I put it as here, never. But there might be some situations, just in case if you get some errors inside it, or just in case if you get some problem, you have given option, restart policy as always you can put, or on failure. If just in case if the container got failed, it will try to restart. So in our state, so in our job, in our manifest file, so is it good to put it restart policy as what? Which one is good to put here? Never. Clear? Online, this is clear? Jobs concept? So, very good. So, non-parallel jobs, you understood? Parallel jobs with fixed count, parallel jobs with a work queue. So work queue meaning these jobs dynamically scale pods based on the workload. So it doesn't have any fixed, does it have any fixed completion count here? No. Because based on the dynamically inputs that you get, those many parallelisms. If you mention the parallelism as 3, that means three set of pods will keep on created. That is what? Work queue. So whenever you mention fixed count, completions as 5, completion as 6, and parallelism is 3. Then what concept is that? Parallel jobs with fixed completion count. That meaning 6 pods will get created each time of 3. That is called parallel jobs with fixed completion count. And if you just put only completions, then non-parallel jobs. One by one, sequentially it get created. Good. For that, same thing that I took it. So, but here what I'm mentioning is completions as what? 3. So when I take this, let's go and create. Okay. Where I call it as, which one is that? Non-parallel dot YML. See now here. Guys, API version is what? Batch v1. What's the kind I'm using here now? Job, and name is non-parallel job, and template is blah blah. And then how many containers I'm creating? How many containers I'm creating here? 1 container. So under these containers, how many are there? Only 1 container. 3 times it will get created, but how many in one part? How many containers are there? Only 1. So what's the image I'm using? busy box. And what's the command here? What's the command here? I'm using echo hello from non-parallel jobs. So that meaning this command will execute it. So restart policy has given as never. Completions I have given as 3. That meaning how many pods will created one by one? 3. At a time it will create only 1. Should we go and do this? Okay. So what's the command to execute this manifest file, to run the manifest file? kubectl, apply also you can do, create also you can do. So apply -f, which one? Non-parallel dot viable. Guys, see here. Kinda? Okay. See here, kubectl apply. Before this, do you have any pods on here? kubectl get pods. Okay. Now watch without blinking your eyes. Because how many pods I have mentioned there? Completions 3. Fatafat it will create. So I'll do here get pods. So it will go as 1/3, 2/3, 3/3 it will go. Let's do. So before that, let's run. kubectl apply -f. Which one? Non-parallel. Got a? Okay. How many are there? 0/1. Now another got created here. Now third one got created. Now completed or not? See here, how many pods got created here? Only 1 pod. Next year, how many pods got created here? 2 pods. Next, how many pods got created here? 3. So this is one by one. It is executing the commands in the pod. So this is called non-parallel jobs. In that command, you can put anything. It can be anything in that container. It can be install nginx or if run whatever the things that I'm putting an example as one small command. Okay. So this is what called here non-parallel jobs. Okay. If you want to see the logs, what's the command? And by the way, what is the command to list the jobs? kubectl get jobs. How many jobs are there here? 1 job. And how many completions are there here inside it? 3 completions. Or 3 are done or not? What is the status of this job? Complete. You see, all are completed. The status, previously you saw the status is container creating is one state, pending is one state, running is one state. And now you are seeing completed. Good. How to check the logs? kubectl logs, and you can give you can see the logs from the job also. You can see the logs from the pods also. If you want to see from the job, -l, what is the job name? Job -name. What is the job name? Non-parallel job. Do you see this? What is the job I have mentioned in the manifest file? To print hello from. So how many completions I have given? 3. That meaning how many times it should print? 3 times. Now you got the job. Got it? So if you want to see the logs from the pod, so kubectl just logs and put the pod name. You just take any of the pod. Each pod ran how many times? 1 time. That means how many lines is printed? 1. Got it now? All lines is clear? This is non-parallel jobs. So if you have the parallel, what is the next thing? Parallel jobs with fixed completion count. So for that, same thing will be there. But additionally, what you need to mention? Parallelism. What did you mention here? Parallelism. So, okay. So I have it. How to delete it? How to delete the job? First get the job. Get job. kubectl delete job, or how to delete? kubectl delete -f and then manifest file. Okay. Okay, I don't have anything. So now let's go with what here? Parallel one. Do you see? Same thing what we have, but on the last what we have here? Parallel. So I call it as parallel.yml. Okay, see this here? This is also doing the same thing. Hello from parallel fixed count job, restart policy never, completions is 6, and additionally what I am giving here? Parallelism as 3. So that meaning what will happen here? So 3 jobs, so 3 pods will get created parallelly. So how many sets will be there? 2 sets. So let's try. Tell me how to run this. kubectl apply -f. Okay. Dead pods. How many are creating now? One is completed. You see? Understood? So do you see initially how many sets got created here? 3, and one by one it is getting completed. So once those are completed, then it is creating the next 3. And all the 3 one by one is getting completed. So now the job is completed or not? So this is called what? Parallel with fixed completion. Like this, similarly what you have, last one is just only put parallelism. You can try it out, otherwise you can ignore. Clear enough? Online clear? Online, can I get CC till here, please? Nice. Okay. So whenever we heard about the jobs, guys, whenever we heard about the job, the first thing that we get in our mind is what? Cron job. Oi, it's disturbing me. Okay. So hold on, concentrate. After that, you play whatever you want to do. Okay. See here. Whenever we talk about the jobs, so the first thing what we get in our mind is what? Cron job. Remember cron jobs? So based on the schedule that we do it, right? Do you see this here? Did we delete it? We haven't deleted. Okay, how to delete it? Other way also you can delete it. What is it? Delete -f. Which one? Parallel. Deleted or not? So everything got deleted. So kubectl get pods. All are done. So vi, so cron.yml. Okay, see this? Concept is same, but there is a small difference. What's the API version we are using here? Batch v1. And then what's the kind here? Cron job. So previously we used what? Just only job. When you use just only job, we have 3 types there. What is that? Non-parallel, parallel with fixed completion, and then yes, parallel with the work queue. And then here the kind is what? Cron job. Cron job meaning specifically. Okay, you see this. The kind is cron job, and here what I mentioned? Schedule. What I mentioned here? Schedule. We learned this a lot already in the Linux classes. Remember how to schedule it. And if you put */1, that means it runs every 1 minute. Remember, there is a cron job guru, something is there. We went and then created multiple times crons, right? And then what do we have mentioned here? Job template. So every minute, what job needs to be executed? This is the job template. So inside the job template, we have the template. I mean, how many containers are there? Only one. So inside this, it is just printing here, echo hello from Kubernetes. So that meaning every 1 minute, what I'll get printed here? Hello from Kubernetes. So if you want to schedule, it, then you can go for this cron job concept. So here, how to execute? kubectl, apply, -f, what's that? Cron. So if you want to get the details of get cron jobs, what's that? kubectl. So do you see this? Hello cron job is there, and then it will run every 1 minute. And in that manifest file, we have mentioned a command called echo from, hello from Kubernetes. So this manifest file, this job will run every 1 minute. So if you have some schedule things to do, you mention that in the manifest file, and then you can do the cron job through the Kubernetes. Got it? Online? Online or clear? You see? So the pod got created and it is completed. So like this, every 1 minute, the pod will get created. Whatever that you have mentioned inside the manifest file, that will get executed and then it will get completed. Like this, pods will get created every 1 minute. So 1 minute not happened, 41 seconds, 43 seconds. Yes, you can write the manifest file for that, Pranjal. Do you see? One more pod got created 4 seconds ago and then complete. Like this, every minute, if I don't stop it or if I don't delete it, continuously pods will get created and then it's not good. But if you have any requirement like this, no issues. You can just go and create it, nothing harm inside it. So if you want to delete the cron job, kubectl delete, and then first kubectl get cron job. What's the cron job? Hello cron job, right? So kubectl delete, which one? Cron job, which one? Hello hyphen cron job. Got deleted now. So now pods will not get created. So you all understood about the jobs related thing in Kubernetes. We also have something called scheduling. What's that? Actually, we could have clubbed that topic also here, but I'll not be clubbing it. I'll be taking that topic separately. So that concept is also very nice. We call it as taints and tolerance. What's that? Taints and tolerance. Taints and tolerance. And then also no definity. These concepts are there. So I'll keep that because I know when to take what topic. Okay. So till here on the jobs, it's good to do it. So is this clear? Are you comfortable with all the commands of the Kubernetes till now? So we have been learning so many commands, right? So I'll stop it here. From tomorrow onwards, whatever that we have done from the single host concept, from tomorrow we'll go with multi-host. That meaning which tool we use? KOps. So tomorrow onwards, what we do, we go with the cluster base. That meaning multi-host with the KOps. So that meaning how many machines minimum we'll go for it? 3 will go. One is master, 2 are worker nodes. One is master, 2 is worker nodes. And then tomorrow we'll go and set up using KOps. So it will take time to set up the cluster, at least 10 minutes maybe. After that, same concept, same commands will run. The only difference is here the single host, it is multi-host cluster. So as we have 10 minutes more, so yeah. So here, let's give me introduction about it, and then I don't create it, but let's see some introduction. So KOps meaning here, Kubernetes operation is a command line tool that helps you to create, manage, upgrade, and destroy Kubernetes clusters on cloud providers like AWS, GCP, and more. So these KOps will be used for multi-cloud providers, but especially which one here? AWS. If you want to go for production grade Kubernetes cluster on AWS, then we would suggest KOps. There are multiple tools are also available, as I said, but in my company also we are using what? KOps only. Okay. What's the advantage, Nana? Automatically, see, here we have launched one EC2 instance. Yes or no? Today, what we did till now, we set up one EC2 instance, and inside this, what we install? Minikube we install. Yes or no? And then we run everything inside it. But from tomorrow onwards, what we do? Listen carefully. First, we launch EC2 instance. Okay. We log into the EC2 instance. We will install kubectl. Okay. From here, we'll attach one IAM role, admin role. What's that? Okay. We'll run some command here. Once I run the Kubernetes KOps, we will install KOps. What are the things we install here? We install KOps that also contain what? kubectl. These two will be installed. Once I use KOps command, create a cluster, mentioning master node as 1, worker node as 2. Master node, I'll go with T2 small or medium, right? Worker nodes also ఉందా లేకుంటే బాగుండదు. Okay, so T2 small, T2 medium, or also T2 small, your wish, but master node. But I told you already, does the master node will take the load? So basically, T2 medium should be on worker node. T2's, this is T2 small is also fine because it's a master node. So we don't execute much over there. Okay, so now what happens is, how many masters I have mentioned? How many worker nodes I have mentioned? And I run that command here. Once I run that command, automatically one master will create and 2 worker nodes will get created. That will mean total how many we need? 4. How many we need? This is, you can call it as, what machine you call this? KOps. You can call it as KOps machine, or you can call it as a broker machine, right? Or you can call it as a controller, Kubernetes controller, you can say, whatever you can say. But in this master, what do you have? We have the API server, right? And then we have what? kubectl will be here. We have scheduler, we have etcd, and then we have what? Control manager. And here we have kubelet and kube proxy, right? And then container runtime will be there, right? And then also same thing. So this will, everything is completely managed by this KOps. Nice, no? So otherwise you need to set up this manually one by one. So instead of that, what we have, KOps will install, KOps will set up master and then worker nodes automatically. And then we will not be logging into these machines at all. All the commands will run it from here only. All the commands will run it from here. But we'll run the commands. This will, API server will take the commands and then it will execute it on, or schedule the pods on worker nodes. kubectl command, same commands will work. The only difference is, till now we have worked on single host. Now this is multi-host. Concepts are same. Here in single host, the same machine will act as a master. The same machine also worked as a worker node. But here from tomorrow, it will be separate. Clear the architecture of KOps? Online? So that's what I said. Automatically infra creation in AWS will be handled by this KOps. So if you want to deploy high availability Kubernetes master, go for it. And it supports what? Rolling updates. And it supports homogeneous and heterogeneous cluster. Homogeneous meaning same type, like Amazon Linux or Ubuntu, same type. Or if you want different types also, it works. So what are the alternatives for it here? Remember EKS, and we use Minikube, we use kubeadm, right? And then Rancher. So Terraform, no, I don't recommend Terraform here. So with the Terraform also, you can automatically create the infrastructure or not. So KOps will create a production level cluster. It's a third party tool. It is not a native tool. It's a third party tool, right? This one will go with the T2 micro only. This KOps, because we are not, we are installing only KOps and then what? kubectl. So T2 micro is fine. And tomorrow we'll go with what? Amazon Linux 2. And then we'll make sure that IAM role is attached with admin permissions. Why? Because when we run this command, it needs to go and launch EC2 instance. For that, we need to have a role. So role need to be attached. And then we'll install what on here? kubectl and then KOps with this. And then we'll do some small configurations here. And then tomorrow, I'll show you how to set up KOps manually first. And from day after tomorrow, script is there. Tomorrow, we'll go with manually. Okay, good. So we'll be able to complete the practical still here. So what did we discuss today? We started with what? Deployments, jobs, and then cron jobs. Cron jobs also will come under jobs only. 2 topics. Okay. Good. So if you understood, can you give the final CC for today, please? And upload the task in the Google Classroom. So please complete it. Okay. See guys, how much time it is, how much time is taking for you to complete the practicals? Tell me honestly. 1 hour, no? Huh? Just imagine DevOps, AWS and DevOps practice. You are taking just only 1 hour. It's good because maximum you are learning from here only, and concepts you are able to clear here only. Practicals also you are able to understand here only. The only thing what you are doing is practicing by yourself. Otherwise, there are so many people spending the entire day sitting in the lab doing that and this with the same concept. Right? So please utilize the time, and then there is one task on me. We will do it today. Okay. I need to upload all interview questions. That is getting out of my mind all the time. So we'll do it. Okay now? Okay. So can you give the final CC for today, please? So that is all. Let's connect tomorrow with the KOps. Until then, take care, guys. Have a nice day. See you tomorrow. Bye.